Hello, welcome to the project Drone Human and Car Detection with tracking. I've used YOLO version 26 for the detection task and used the BOT SORT model for the tracking task. So this video we will show the implementation. This has been well documented in the README file. As you can see, all the steps are well mentioned, and the output files where we will find the respective files is also there. Before going to the implementation, let us see the dataset. So the dataset's name is BaseDrone dataset. It is a large dataset containing of images captured with the help of drones. And let's see the YAML file. So this dataset will not be using it in its raw form, but it helps to see what is inside the dataset. So there are 10 classes, as we can see, and for us, the important classes are pedestrian, people, and the 3 and 4, the car and van. We have combined the car and van to be included in the car category and pedestrian and people in the human category. We could have added the trucks and buses also, but we didn't for this project. So this is the original YAML file, but we'll not be using this YAML file. Let us see the YAML file we will be using after we run the preprocessed documents. So let us start with the implementation. So the first task is to clone and install the required projects. So we will do it in the Colab environment. So we could have done it in any terminal based applications. We could have done it locally, but I am using Colab so that I can leverage the GPU that I get from there. And the next step is to download and extract the dataset. So let us run this. This step will download the dataset from the Kaggle and it will extract the dataset. So we just got this link from here. There are different options with which we can download the dataset. We have chosen the curl option because it's easier and also it doesn't require any authentication from us. Okay, so the dataset has been downloaded. As we can see, it is 100% downloaded. So our next step is to pre-process the dataset. So we will run this command and we will see what this step does by looking at the code. So in the pre-processing, there are basically two functions. The first one is to remap the labels. As I previously mentioned, that we will not be using all the 10 labels here. We will be only using two labels. That is 0 and 1 for pedestrian, I mean human, and 3 and 4 for cars. So this is what we can see. 0 will be mapped back to 0. 1 will also be mapped back to 0. And 3 and 4 both will be mapped to 1. So this is the task of remapping labels. So it will go through each of the text files in the VisDrone dataset, and within each of the text files, it will modify to remap the original labels into these labels and remove the other labels that are not uh, required for this project. So this we can see the dataset is already here, and also the GitHub project is also cloned here. So let us see the remaining part. So this one is the first part, and the second part is just simple visualization where we will sample some random images and we will plot to see how they look like. So let us run this pre-processing task. So this is very easy. We'll just have to run the preprocess.py file. So it has started the remapping labels and it has said the ultimate distribution that we got. So there are around almost 220,000 cars and around 147,000 humans in the total dataset. And this sample visualization is saved in sample visualizations.png. Let us see the file. So as you can see, there are the red marks one are cars and the green ones are humans. This is a one human. This is one human being. So this has come from the original dataset, and these are the train images, so that you can see how the dataset looks like. Okay, so let us get back to our main task. So our next task is to train the model. So the training the model is also very easy task. So we can see the code just from here. So this is probably the simplest code here, though this is the main task. So we can see there have been 50 epochs mentioned. Image size is 640 batch size, patience for early stopping criteria. Everything is mentioned here, and we are specifically using the yellow version 26 and the nano model. So this performance will be seen here is not representative of the bigger models. This is the nano model, that is the smallest possible model. If we want to increase the performance, then improve the performance, then we should use the larger models available. And I'm just changing the 50 epochs to 2 epochs so that we can see how the project works for now. And later, when we need to improve the performance, we could have just reversed the 50 epochs to 2 epochs. So let us run it for 2 epochs. So this one is also very easy. Uh, we just have to run the training script. See, the training for 2 epochs has been completed. So this process will be same if we train it for more epochs. So we just have to increase the number from 2 to 50, which was the default here. So we did it just to show how the training process is done. The process is actually same. So the last and base checkpoints has been moved to the root directory of the project, and we can see some results that has been saved to the yellow version 26 folder that is inside of the runs. So detect, then runs, and then the Visdrone yellow version 26. Then we can see the different results there. So all the metrics like box loss and the instance loss, and also the class loss and mean average precision, everything has been is saved there, and the results is also saved there for different box loss, classification loss, and other losses. So this process is the same. So we have come up to this portion where we have trained our model. So our next tasks are very easy. So next task is to detect using the model, and then track using the method we have stated earlier, and the last one is to evaluate the model. So let's start with the detect option. It has run, and the outputs has been saved to the detections folder. So output and then the detections folder. So this image is the result of 20 images that has been run. So let us see this object image to view the result. So this is the image. As we can see, there are this one is mentioned as a human. There are some humans that the model has not able to pick because this model has been run only for 2 epochs. So if we could run it for more number of epochs, hopefully the performance would be better. But you can see within the 2 epochs, the model has been able to capture most of the objects in its vision. Okay, so this is the detection task. So next, our next task is the tracking. So for tracking, we've already kept one video in the GitHub repository. You can use that, or you can also use your own video for the tracking task. So just run the python track.py and then mention your video name. So for our case, we'll mention the test video. So we'll run the python track.py, and our video name is test video.mp. So once we run it, it will run the tracking task on the particular video. After it runs, let us give it some time, and we run the next one, that is the evaluation part, and then we will see the okay. So the tracking has been completed. So let us run the evaluation script, and once while this script is running, we'll go back to the tracked video. So the 961 frames of my test video has been tracked, and its output has been saved to track output .mp4. Okay, so let us see the evaluation script first, and then we will go back to the output video. So the evaluation script, we can see the mean absolute precision and other losses in the um, test, and the final results will be reported here. As we can see, the precision is 63% around, and the recall is 27.19%, and the output has been saved to evaluation plots.png. So where is this? So this one is here. So this is the evaluation plots. Here we will also see multiple evaluation metrics that has been evaluated over this model. Okay, so let's see this image. So at the right hand side, you can see the confusion matrix where you can see the predicted levels of human, car, and background and the actual levels. And we can see the performance of the model. Okay, so the other losses are mentioned in the left hand side of the. Okay, so let us now go back to see the direct output MP4 video. So this is the video, and we can see the car is moving here, and it has been tracked with the tracking algorithm. There are some humans. All the humans are with green level. We can see this is a very tough uh, human to detect, but the model has been able to sometimes detect this. But the cars are detected more better for using this model. I believe the performance would increase once we train it for multiple epochs, or if we even use the larger versions of the model. Okay, so this was all with this project. Thank you.